Alright, so I'm gonna do the problem with the where is it? The one where 8b, it says where are the hottest points on the square plate bounded by x equals 0, x equals 2, y equals 0, and y equals 3. I think this is actually the way to do it. This is the only way I can really think to do it. So pretty much they give us our function because that function applies to all parts of the problem. So we have x cubed plus I don't know, x cubed plus y cubed minus 3xy. So pretty much what we have to do that I didn't do. Okay, so I just took the partial derivatives of x and y of the function, but I didn't find the critical points. I was just lazy to do all that freaking substituting this equation to that and then back and forth. But technically you're supposed to find the critical points. So I'll leave that up to you to do the critical points since you also was having trouble. I just didn't feel like doing it to save time. But anyways, so I just pretty much drew out the the things they gave us. So they gave us x equals 0, x equals 2, y equals 3, and y equals 0. So that pretty much just creates our little box here, right? So pretty much the way I like to look at it, first I labeled each line. So this is line 1, line 2, line 3, and line 4. Go label however you want. And the you need to label these points. So this is the origin right here, 0, 0. And then here's 2, 0. Because the line x equals 2 and you're still on the x-axis, so it's 2, 0. Same thing here. You went across 2 and you went up 3 because the line x equals 3. Same thing here. You went up 3 only because this is x equals 0 and then you're at y equals 3. So pretty much you get these coordinates. So pretty much it's pretty easy. All you have to do, you have to look at each line. So I looked at line 1 first. So pretty much what you have to do, you have to you have to look at what's common in the 2 points. So on L1 you have 2 points, this point and that point. So you have 0, 0 and 2, 0. You have to look at what's common. So the thing is common is that this right here, the y value for that and that is common. Oh, the y value, yeah. You see the x here you got 0 and here you got 2. That's not common. Here you got 0 and here you got 0. So now you're pretty much gonna say, where is it? So on line 1, y equals 0. So what are you gonna do? You're gonna plug the y equals 0 into the original function. So when you plug that into the original function, as you can see, this will be gone, this will be gone, so you're left with x cubed. Now you have to just pretty much evaluate the 2 points inside that new function that you just got from evaluating the original function. So when we evaluate the function at y equals 0, we got x cubed. Now we have to evaluate the points at I'm sorry, we have to use the points and evaluate in this function. So when we plug in the point 0, 0 from, we're just evaluating these points. So 0, 0 and 2, 0. So when we evaluate 0, 0 into this function right here, we get 0. And when we evaluate 2, 0 into this function x cubed also, we get 8. So pretty much you can just pretty much tell which is the local min and max by the values. Same thing here on line 2. Let's look at line 2. So here, what's common on line 2? Let me erase this so it's not confusing. So on line 2, x and x. You see it? The 2 here is also common with the 2 here. So now we're gonna say pretty much the same thing. Where is it? Okay. Well, this is x. So x, we're pretty much saying x equals 2. So we do the same thing. We plug in 2 back into the original function. And I don't know if you can see. So when we plug it in, we get I think I did that right. Yeah, 2 cubed is 8, and then plus y cubed. Yeah, you get that, and I just rearranged it so you get y cubed minus 6y plus 8. So now you get this new function. Now you just have to test the 2 points. So we testing the points on this line. So we look at this line, we just disregard everything else. So we just look at 2 0 and 2 3. So pretty much we just evaluate the 2 points 2 3 into this new function right here. I just rewrote it here. So when we plug it in, we get 0. Hopefully, yeah, I think I did that right. And when we evaluate the 0.20 into this new function, we get 8. So pretty much again, you can tell which is a local minimax. Let's look at the third line. Where the hell is it? Oh, it's up here. So pretty much let's see. Yeah, I'm gonna upload this YouTube. But anyways, we look at line 3. So up here, so what's common again is erase this. Y. So you can tell here, you have a 3 and you have a 3. So that's pretty much whatever's common you're gonna set into the equation. So here we have y equals 3. So pretty much we say y equals 3, we're gonna plug 3 back into the original equation. That's pretty much the first step, and we're gonna get our new equation. So our new equation, we got x cubed minus 9x plus 27. Now all we just have to do is evaluate the 2 points on the line. So we cover up everything else, and we look at the 2 points, 2 3 and 0 3. We evaluate the 2 points inside this new function, and I got 17. Hopefully I'm doing the math right, because I'm just doing it off the top of my head. And here I just do I evaluate 0 3 into this new function again, and I got 27. Looking at the things, you can see which is local minimax. And finally, just look at the line 4. Pretty much you just do the same thing. So line 4, we have 0 3 and 0 0. So what's common is that the x equals 0. You're probably wondering like why we're using 0 0 again. It's because this is like a different line. This is line 4. So although we use the 0.00, we can use it again. So pretty much we do the same thing. We plug in x equals 0 into original function up there. So we get just y cubed because everything else will cancel out. So that's our new function. And we evaluate the 2 points. So our 2 points up here, 0 3 and 0 0. So pretty much we just evaluate these points into this new function that we got. So we got 3 cubed, which is just 27, and we evaluate 0 0, which is just 0. So this is a local min, and that's a local max. So pretty much just to summarize what you answer, I'm guessing this is what the question is asking, is pretty much what are like it says where are the hottest points on the square plate. So pretty much I guess the hottest points is the local max, but I wrote the local max and mins. So pretty much to determine the local max, you just look at the highest values. So you gotta look at like lines 1 2 3 and 4. So you just look at the highest value you got. So the highest value you got was 27 here, and I also got 27 here. So those are I'm gonna pretty much say the local max at the points, which is 0 3, and I think I did that right. Let me just check. Yeah, it's just gonna be, yeah, this should have just been 0 3. I wrote this doesn't have to be here, because 0 3 is 27, and also here 0 3 is 27. So my local max is just at the point 0 3, so it's just gonna be there. I guess since it acts at the hottest point, which is, I'm guessing this is gonna be answered because we never had a question like this, but I would just write this as the answer, the local max at that. But don't also forget to do the critical points from the partial derivatives of x and the y. I just didn't do it.